Hello and welcome to the Cuyamaga Institute, our Q&A Conversation for Exploration series. I'm Paul Robert, the Executive Director and President of the Institute, and along with my wife, Laura Lee, the Director of Research, Education, and Outreach, we want to thank you for joining us today. The Cuyamaga Institute is an independent, nonprofit research organization committed to researching consciousness and the human experience following the footsteps of our founder, anthropologist Dr. Felicitas Goodman. And as an educational institution, we recognize to thrive that we're going to take an open approach. So we invite scholars in related fields to help broaden the scope of our own work and exploration, and that's why we call this Conversation for Exploration. And on these Sunday discussions, we've had a full spectrum of topics, from the arts to the sciences, and everything in between. And we invite you to visit our website at CuyamangaInstitute.com. All of our presentations are free, and as a nonprofit, we invite you to become a supporting member. And of course, we thank you, the community members who continue to support the mission of the Cuyamaga Institute. Let's step outside and look up at the cosmos. Let's take a time for some exploration. Let's talk a little bit about what's going to happen in terms of our relationship to the planets, to the universe, and this search, this ongoing search for life, that connection of life that is beyond Earth. And science continues to show us more and more evidence of life. In fact, there were some discoveries happening, or even in the last few days, that I was going to show a slide of, where they found water on Mars in a new...
Lots of water.
Lots of water. And this canyon, they're saying that it's, 10 times larger than the Grand Canyon or something. I have a picture of it. I'm going to show it while I mention this. So, yeah, I thought I would just show that this massive version of the Grand Canyon, this is significant to today's discussion because obviously where there's water, there's life. It's part of the whole cycle. So we want to continue to
where there's life, there's water.
If that's what I meant to say.
Yeah.
Or both. Yeah. So anyway, that was that. And so I thought I'd throw that out there. I also want to mention that last night, I'm sure you all took a chance to step outside and enjoy the full moon. It was the longest full moon of the year, and pretty powerful stuff. So we here in Arizona had a perfect clear sky, and God, it was just so powerful and so immense. So anyway, I'm going to close this, Laura, and let you go ahead and do more of an introduction.
Well, it's a significant season also with the solstice coming up, but also astronomically, we've got the James Webb Telescope, the most complex piece of technology as yet invented. We're going to speak to that. But we're celebrating this season with a tour of the cosmos with Professor Ed Turner. It's an exciting, wondrous beat that he has, the birth and death of the stars that give rise to complex matter and life, water on Mars. Throughout the visible universe, we see the signature of water. We have new tools to detect exoplanets outside our own solar system. Astrobiology, the search for life out there, all the better to ponder if we're alone in this universe or if we're in this cosmic womb of creation. The dark matter, black holes, the limits of reductionist science, AI being the best candidate to go where humans are not designed to. Sorry, Captain Kirk. The nature of consciousness, I think that's the real final frontier. We're going to go exploring. And our guide today, Edwin Turner, Princeton University professor of astrophysical sciences and statistical studies, working in both theoretical and observational astrophysics. Ed has published over 240 research papers on binary galaxies, groups of galaxies, large-scale structure, dark matter, quasar populations, gravitational lensing, the cosmic X-ray background, the cosmological constant, exoplanets, astrobiology, and the origin of life, here and elsewhere, and statistical analysis. He's very fond of the Bayesian inference, a strategy for common sense analysis. He's a member of the Breakthrough Starshot Initiative, and his friend and colleague Avi Loeb, who we interviewed recently, invited him to join the Galileo Project. That's quite the CV. We welcome you, Ed, and thank you for being here with us today. Thank you for all the work that you're doing, helping to make this cosmos more accessible to all of us. So, and before we get started, because we are celebrating the launch of this amazing tool to go into space, its imminent launch, I want to do a little bit of networking and introduce Tony Hull, our good friend and member of our community. Tony Hull is a astrophysicist, adjunct professor at the University of New Mexico, frequent guest here on our Sunday talks and commentator. And Tony has led the team of 60 polishing the mirrors of the James Webb Telescope, among other projects. And Tony, welcome.
Oh, well, thank you very much.
Tony.
Yes, hi, Ed.
Hi.
Yes, and that was my function, and it was really interesting. Paul, were you going to show my slide, or?
Sure, I'll do it right now.
Okay.
Yeah.
We just have to insert this because we booked, Ed, we booked you because you were about to go to the Conley Institute for Physics and Mathematics of the Universe. That's why we scheduled you, but it happened to be also this very significant date. And so this is a celebration of all the tools.
Here we have it, Tony.
Yeah, and I simply was going to say, this is what it looks like. And Laura quoted John Mather, who described this as the most complex scientific instrument ever developed. And I agree with him on that. There are about 440 failure modes that we have to be concerned in, even today as it's launched. And that's part of why it's been taking a long time to develop and gotten to be pretty expensive. It's been tested and retested in so many ways. The launch is going to be, if you go back one, Paul.
Here, yeah.
Yeah, the launch is going to be on December 24th, as Laura said, 7:20 a.m. Eastern Standard Time, and it will be a little earlier for us out west. Next slide, please. And this is just a quick image of what it was like to polish the mirrors. This is not done in the way you might associate with it. This was done, it took a team of 60 over 5 years to do the 18 primary mirror elements, as well as the secondary and tertiary mirrors. And I had the privilege of leading that team. Well, I couldn't resist throwing in my moon picture over Cabazon this morning. And you see that it doesn't show the moon clearly. It just shot with my cell phone. And the next, and one of the things I've enjoyed about the pandemic is, and enjoy may be a strange word, but I'm here as opposed to traveling almost constantly. And every morning I get up and watch the sunrise, and every evening I try and watch the sunset. And this is the sunrise this morning, in the position it will be, and for all practical purposes, on the solstice, which will happen on the 21st, as we said earlier here. But this is the scene today, and I want to point out, you can just barely see, but I put little lines of pebbles to mark each of the solstices and the equinox, and I rather enjoy watching the sun dance back and forth between those. It's as far right as it's going to be now, and it's going to reverse on the 21st and start moving over the landscape you see and beyond. Well, that's what I have to say. I wanted to encourage anybody that's in a position to watch sunrise or sunset, put a marker down. You may enjoy seeing how things move with respect to that.
You know, it's really about the technology that we've employed since time immemorial to celebrate the stars, to celebrate the universe and our place in it. And with the launch of this James Webb Telescope, so significant. I mean, the Hubble was groundbreaking, and this is what, Tony, like 10 times more powerful, bringing in that much more data. And it really helps us to expand our bandwidth and collect data, and to really understand our place in the universe and what's going on in there.
Well, one thing that it does do,
our huge backyard,
it is not identical to Hubble in many ways. One of which is it operates in the infrared. There's only a small wavelength overlap, and it does this driven by several requirements. But one of those is to look very deeply at the early universe, and to do this, light is shifted from the way we would see it and the way it originated from its source. As we observe it, it's shifted way into the red, as many as 30 times a change in wavelength.
Let's hear all about this on the 30th. And bring your friend Bob Woodruff, who has also attended some of our Sundays, because he helped design the Hubble. So let's celebrate all of those technologies with you on January 30th. You're going to come back?
I will mark it in my calendar.
We're going to hear the whole story of the
man.
and what went into it, and celebrate the scientists and the engineers who have designed these and employed these. So
Thank
this'll
you,
be
Tony.
great. Thank you
Thank
so
you.
much,
Again,
Tony.
yeah, fabulous.
Yeah, there's so much to say on this.
Yeah.
So
Well, let's
January 30th.
reintroduce Ed here and
Well,
get started.
well, I met Ed because when Avi Loeb was here talking about the Galileo project, there was something that I saw in a Discover magazine article that was showcasing Avi's work and Ed. And Ed said something that really caught my attention. He said, I have, how do you put it? I have unfettered imagination along with rigorous curiosity. What was it? Along with methodical... I have that quote here somewhere. So, and I thought, this is a man I want to know.
But
So,
in your own words.
I have to know this man. This is a scientist who's also so open-minded.
Well, thank you, first of all, for the invitation, and I'm looking forward to talking about all of these, or some of these fascinating topics that you listed a bit ago in the introduction. I think what you're referring to is I was interviewed by someone for that article and by the reporter, and tried to make a distinction between different areas of different modes or parts of doing research, and the role of skepticism and rigor versus the role of imagination and open-mindedness. I didn't claim to have an unfettered imagination. I wish, but I think that's what you want for some parts of science, and which I aspire to and maybe achieve occasionally in my own work. But in other areas of science, you want to be just the opposite. You want to be extremely skeptical and hard to convince of things, and to have the highest standards of demonstration and proof before you accept something as true. And I think scientists, professional scientists, very often get confused about that. And people who are extremely good scientists are sometimes very, very skeptical about new ideas, exploring unusual hypotheses and things. And if you look at the history of science, there are many, many times when we have been delayed or held back. Progress has been obstructed by the established scientific community's unwillingness to consider, far out hypotheses like that almost all the matter in the universe is dark and can't be seen. That was, when I was a graduate student, considered almost a crazy idea, now accepted, of course. More, the idea that Avi Loeb was here talking about the Galileo project, the idea that UAPs might represent, the visits from an extraterrestrial civilization, is still today considered by, I would say, the large majority of the scientific community so outlandish as to be dismissed in advance. And at least in my view, it's a big mistake to throw out possibilities or ideas on that sort of basis. On the other hand, a very important principle in science, I like Richard Feynman's enunciation of it best. He said, you should be least willing to believe what you most want to believe. You should be your own most. I tell my students, my research students, you should be your own harshest critic. As you know, when we write a scientific paper, we send it into a technical journal and they get experts to review it and criticize it. You really should have made all of those criticisms yourself in advance. You should be very, very harsh about and demanding about doing calculations correctly, about getting high quality data, about making the measurements as accurately, and knowing what your errors are. The Webb would be a disaster if Tony didn't take that approach to polishing the mirrors. Yeah. I'm sure, I haven't actually talked to him about that. I wasn't involved, but in that kind of work, You have to be extremely careful and double and triple and quadruple check everything. And I just think that's a distinction worth making. That's what I was
What a
saying.
fine line to walk. Because Feynman also said science is the belief in the ignorance of the experts, and that we can never assume that we're at the pinnacle of knowledge. We're always going to overturn what we think and then grasp the next
Expand,
paradigm.
build.
Yeah.
I think that's a very important principle for you and your audience to keep in mind if you're interviewing scientists. There are things that scientists consider to be, established fact, or if you're asked some question in a interview where you're talking to the public or you're making a presentation, to sort of give everything the same weight. But there are things that science, in the modern vernacular, believes to be true, or that are hard established. We've known it for centuries, checked it 1,000 different ways. It's in the textbook. You can bet your life on it, and indeed you do bet your life on it every time you say fly in an airplane or do many different things. There are also things which, as evidenced during the pandemic, the evolving understanding of the virus, there are things which are simply our best current understanding based on the recently available data, and which are quite possibly wrong. Most scientific papers turn out to be wrong. Most scientific ideas turn out to be incorrect. Eventually, it's a process of, someone said it's like trying to drive somewhere on a road that doesn't exist, so you have to build the road as you go. That's so I try, when I teach students in a course, I try to make a distinction between what we know, very, very securely, what we know moderately securely, what's, just our current best guess. And a lot of times that gets, lost in the detail and certainly many of the topics you listed earlier that we may talk about today are things which the most honest answer is we simply don't know.
Oh, I appreciate that. And that's where your Bayesian inference comes in. It's a common sense approach, but it will never actually get to the answer. It's just betting on the answer, isn't it? It's just weighing the odds.
Well, it can be looked at that way. Bayesian statistics is a formal mathematical tool for taking into account what you already know or think you know, and new data. So an example I sometimes give is, suppose I told you that I'm going to Tokyo and I'm going to fly there on, a large jet aircraft operated by United Airlines. Would you believe me? Probably.
Yeah, I would have no reason not to. Or I would say that was your intent. That was your best prediction. Yeah.
Now, suppose I told you I was going to go to Tokyo flying on the back of a fire-breathing dragon.
Mythically, I would say that's a mythic poetic expression. Yeah, not literal. Yeah.
You probably wouldn't believe that. Now, what Bayes, the Reverend Bayes, pointed out, what Bayesian statistics looks at, is why do you believe one and not the other? You believe the evidence, the current data is exactly the same. I just said it. That's all you know. Something I said. But one you'll accept easily. The other, it would be extremely hard to convince you was true. And the reason is that lots of people that have traveled lots of places on big jet airplanes.
I have past experience to compare it with.
Yeah, that's what's called a prior in Bayesian, in the jargon of Bayesian statistics. You presumably don't know anyone that's ever traveled anywhere flying on the back of a fire-breathing dragon. So that's a different prior. So Bayesian statistics is just a mathematical way of combining new data with what you knew before. And
well, which is why Thomas Jefferson famously said about meteorites, I would sooner believe that the august professors who claim that rocks fell from the sky are lying than that rocks fell from the sky. He had no past experience of rocks falling from the sky. Yeah.
Right. It's a wonderful story about meteorites. There was the French Academy of Sciences adopted a formal position in the early, I don't remember the year, the early 19th century, the early 1800s, denying that rocks ever fell from the sky. And but strong enough data came in to reverse that prior and showed that I could tell a whole story about it. It's probably not worth taking the time, but it's a nice historical example of how new data can change old beliefs and so on. And Bayesian statistics gives you a way of doing that rationally, but it's controversial because it does. I mentioned before the skepticism about whether it even makes sense to look at the possibility that UAPs are, due to extraterrestrial civilizations. And that's because of difference in judgments about how likely that is a priori. There's a certain amount of data, reports from Navy pilots and films of fuzzy spots of light dancing around and things. But to decide how convincing that is, you have to think about how likely it is that could be the case based on what we otherwise know about the universe and so on and so forth. So,
which takes us into astrobiology, because that's one of your beats. That's something that you've spent a lot of time looking at. And and we've got to ask, are we alone in the universe? Is it less likely that we're a fluke, or that the universe is replete with life out there? And
yes. Yeah. Well, this is a great example, actually, of a question which is one of the most popular questions astronomers and astrophysicists, whether or not they work in astrobiology, get asked. And I think the most honest answer is simply, we don't know. And that's very boring. I'll try to be a little less boring in a moment, but that's the truth. We don't know. And it's also a topic on which people's priors differ a lot. I believe you made a very common argument in the interview you had with Avi, which Paul, I think, made the comment, well, the universe is so big, there must be life out there elsewhere. And that's an example. I think you said something like that. Is that right?
Yeah,
probably.
Sounds familiar.
But an awful waste of space.
Yes, a famous. So, and that's an example of putting something into the prior, that
chances are
does increase your tendency to believe that. There's something, an argument I've made a lot, which is controversial, is that it's pretty plausible, in my opinion, that the rest of the universe is totally empty of life. I would put the probability of that at maybe, I don't know, who knows, 30%. I wouldn't be surprised. And the reason is because life is so complex compared to the most complicated chemical systems we otherwise know. There's like an enormous gap of complexity between the simplest life and the most complex other systems we know, anywhere in the universe. And
there's a big gap between matter and then sparked with life, where life can organize that matter around itself. That's another huge gap.
Yeah, that is, in a sense, the huge gap I'm talking about between abiotic physical conditions and biology. And if you look in detail at how life works, by stringing together a small number of identical parts, it's like Lego land. You have a small number of different things, amino acids in the case of the proteins, nucleotides in the case of the nucleic acids like DNA and RNA, and they can be strung together in any order, sort of like letters of the English alphabet can be strung together to make any text possible. Every novel that's ever been written, every novel that could be written, every string of total nonsense that could be written. That's what the structure of life looks like. And if you start calculating probabilities for that, you quickly end up with, if that arose by chance, if nucleotides strung themselves together by chance, or the amino acids strung themselves together by chance and to form an actual working molecular biology, it's like...
And that's just on Earth. What about all of space, right? So even more.
It's incredibly unlikely. It's like that old trope about, I'm not sure that's the correct use of the word trope, but that old idea about, monkeys banging on typewriters and writing Shakespearean sonnets. I actually did that calculation once. If you assume that every planet in every star in the observable universe has 10 planets, and every square meter of that of every planet contains a monkey with a typewriter banging away randomly,
Through
at
infinity.
high
Yeah.
typing speed since the beginning of the Big Bang, since the universe began. They still wouldn't produce a single Shakespearean sonnet. Those sort of probabilities are so low as to be essentially vanishing. And it could be that life is that sort of statistical fluke, and that it only exists because we might live in an enormous or even infinite universe.
Mm-hmm.
So even arbitrarily small things, probability events will occur. People really dislike this idea. I dislike it too. It's very boring prediction, but it's an example of what we don't know, and this tendency to believe what we want to believe. For instance, you mentioned the discovery of water on Mars.
Yeah.
Water was not discovered on Mars recently.
It was a long time ago that we first noted it. Yeah.
No, but this most recent discovery is not a discovery of water. It's a discovery of a large deposit. If you go look at the paper in Icarus, the paper, of hydrogen. They're assuming that hydrogen is in H2O, is in water. The paper in Icarus points out that it could be in hydrated minerals. They think that's less likely chemically, and I'm not a geochemist, but I think they're right. The most likely explanation is ice, but the media coverage of it describes it as water. If you read the technical paper, they don't say water; they say hydrogen, and that's a sort of glaring example and typical of. For a long time, I've taught a freshman seminar at Princeton in science and the media, and the media very commonly sort of emphasizes the most exciting possibilities. They're selling.
Caught my interest. Yeah.
But I'm not saying that this shouldn't be a big deal. It is, because it probably is ice. But that's an example of something. Before you take it home, put it in the textbook saying there's water under a meter under the surface of that huge canyon.
Yeah.
We need other evidence to see if it's actually hydrogen in H2O or hydrogen in some other form. Anyway, sorry,
this is what makes all of these telescopes that we're putting up in space so exciting to gather data. And what do you expect will be found? You also look into theoretical physics and dark matter, dark energy, black holes. You cover it all. What do you think we're going to find with some of this new technology? What do you hope?
Well, I very much hope. I mean, it's not specific to me. It's one of the major science goals of, for instance, the Webb, since we're talking about it, to do infrared spectroscopy of the atmospheres of exoplanets, which would tell us or can tell us in some cases, the chemical composition of the atmosphere of these exoplanets. And so, if we find evidence of water vapor, evidence of oxygen, things that are associated with life, they're sometimes called biosignatures or biomarkers, although biomarkers, some other field of science has claimed, but so biosignatures, you would get evidence that there might be, but again, not proof, just
somebody's
evidence.
Exhaling. Yeah,
that something's exhaling. One of the most exciting possibilities, which the Webb, I think, will not be able to do, but some future missions may be able to do, is look for something called the red edge. And the red edge is a feature of the reflectance of the leaves of deciduous plants on the Earth. If you look at how much light is reflected from the leaf of some tree, deciduous means they lose their leaves in the winter, you would see a few percent of the light in the blue, 10, 15, maybe even 20% in the green, and then as you go off towards the orange and red, yellow, orange, red, it would go down again to 5%. Just beyond where your eye can see, just beyond 0.7 microns towards the red, the leaves become like 50, 60, 70% reflective, much more reflective. They're as reflective of very near infrared light as new fallen snow is of white light. If you could see there, if you could see another 1/10 of a micron out into the red, the natural world where there are plants and bright sunshine would look blindingly bright. You would have a hard time seeing anything else. And that makes a very strong feature in the spectrum of a planet like the Earth. We've actually seen it in the Earth's Earthshine, or the Earth's reflected sunlight reflected off the moon back to us. You can see that feature. If we could see that on an exoplanet, there would be an indication of
Life.
Of plant life there, assuming it used photosynthesis similar to the photosynthesis of Earth plants. So there's a whole bunch of tools that are being proposed by theorists and calculations being made, which some of these new space telescopes, including the Webb and others. Before the show, we mentioned briefly a NASA mission called Terrestrial Planet Finder, which would have the capability specifically of looking at Earth-like planets for signs of biology. That mission is now sort of tabled indefinitely, but not, presumably will be flown, or something similar will be flown someday.
Tony worked on that too. Yeah. So when we look at these biological markers and signatures, can we open up the bandwidth to ask, well, what other chemical dynamics other life might be out there? Because you've got to work with whatever planet you're on. And I know silicone-based life, in addition to our carbon-based life, we look at extremophiles at the vents, the deep sea vents, and we see, oh, there's a whole different chemistry going on. You look at dark environments, they're not using light, they're using other chemicals to sustain themselves, to digest and metabolize. And so what has anybody done the experiments? What are the other chemicals that are possible to support life?
There is, well, first of all, I should say this is not an area on which I have a particularly great expertise. The most common speculation is about silicon as a replacement for carbon, as you mentioned. The reason for that is silicon lies on the periodic table of the elements immediately below carbon, which indicates that its outer shell of electrons has basically the same structure as carbon. So you can kind of make chemical analogs. But if you ask chemists about this, biochemists, they're pretty pessimistic that silicon would work for a couple of reasons. One is because the electrons in the silicon orbiting the silicon atom are further out, they're not so strongly bound. So a silicon structure is not as strong as a carbon structure. In fact, if you made like a silicon analog of a protein or DNA, it would be very much more fragile than the carbon versions and might well not hold together. And there are other important chemical differences. Just an obvious one is carbon dioxide, CO2, you know, one carbon atom, two oxygen atoms, is very important in biology and very important, has a lot of important biological roles, where it's not just a greenhouse gas that we're worried about. Plants need it to grow and so on and so forth. It's a gas and it dissolves in water as well. So it's very mobile at reasonable
and versatile. Yeah.
Silicon dioxide, on the other hand, is sand. It just lays there. So, you know, if you try to make a direct analogy of carbon-based life with silicon-based life, there's a lot of parts of it that don't work. That's not to say that nothing else is possible, but it's one of these things we really don't know. And biology is very more than able to surprise us. When when I was in school, I mean, not that long ago, it was said that all the energy for all life on Earth comes from sunlight, eventually, directly or indirectly. We now know that's not true. My late colleague Thomas Onstad at Princeton was involved in the discovery of very deep underground life that lives, its ultimate energy source is natural radioactivity in the rocks. There are radioactive elements deep inside the earth. They decay, they emit radiation. The radiation interacts with the surrounding environment and produces chemical disequilibrium, things like methane. And then there are microorganisms living miles underground that use those chemical byproducts as an energy source and live an extremely slow lifestyle. They may reproduce once in a decade or a century instead of constantly like things on the surface.
But that's one signature of life. It moves chemicals around. And some have posited that bacteria is the most populous and just use us for harnessing transport, right? So this gets back to really the chemistry of the universe and the life and birth and death of the stars. It's in those furnaces of the stars dying that we find these higher elements of life and all these various properties. This is so much the sum, more than the sum of the parts, right? When atoms choose to recombine and create these higher elements, makes it all possible. Can you describe that? I'm rather fascinated that the stars have a life cycle just as all life does.
Well, first of all, I should say it's a metaphor. Stars are never alive. They are not born.
I speak mythopoetic.
Yeah, but
you speak science.
It's a very useful way of thinking about them. I like to mention that caveat simply because I have had students in some of my courses have incredible misunderstandings because I used biological metaphors. We sometimes, when planetary orbits change, we sometimes say the planets are migrating. And I discovered when I read one student's final exam once that they imagine that the planets, you know, sort of swim around and go back to where they came from and reproduce. And
like the salmon?
Yes, like the salmon. But yes, the universe, and in particular stars, have, you know, it would be easy to wax sort of semi-mystical about their connection to life. You know, were once thought to be very distant, but the chemical elements, other than hydrogen and helium, basically, which arose in the Big Bang, all the rest of it, and you know, we have a lot of hydrogen in us because we have water, just like Valley and Mars, but otherwise, we're not. Helium plays no real role in life. Everything else was made in the fusion reactions in the middle, in the cores of very massive stars, and in some cases exploding stars. So, you know, the old song Woodstock, we are stardust, we are billion-year-old carbon. Is that the line, I think? A Joni Mitchell song, I believe, from the 60s. I was actually at the original Woodstock. But anyway,
wow.
An old hippie. But that's sort of literally true. The material in the gas between the stars is disturbed by various processes, starts forming dense clouds. The clouds become self-gravitating. Their gravity slowly causes them to contract, and eventually they get dense and hot enough. The contraction heats them, and that nuclear reactions start, and then they burn they shine as a star, burning hydrogen into helium and helium into heavier elements for the more massive stars until they run out of nuclear fuel, and then we say they die. And if they're massive enough, they explode and throw this material back out into space, where it takes place in the next generation of star and planet formation. And we can see.
Big sneeze. Yeah.
So it just sort of builds up this chemical gunk, let's call it, out of which life arises. And the thing that's even sort of cooler, in my opinion, is that low mass stars like the sun don't really contribute to this. If they're less than 2 or 3 times the mass of the sun, a few times the mass of the sun, they don't really return the material to the interstellar medium. So they're kind of not very helpful, you might think. But actually, those are the stars which provide stable enough. Low mass stars burn much longer, they provide a stable enough environment
For the
for
incubator for life.
to
Yeah.
be an incubator. So it's like all the stars help. The high mass stars don't live very long. They're probably not, they're very violent, they explode, they produce a lot of deadly UV radiation. They're probably bad places for planets to circle and have life, but they produce the material of life. And then the planets circling lower mass stars have a more stable environment and more.
So they each have their role, as in any biosystem, diverse ecosystem. So how does a hippie who went to Woodstock, who was intrigued with all of that, end up where you are? What's your trajectory? How did you? Okay, you ask it.
You just asked it. Good.
What led you to
yeah.
search for answers of the big meaning of life among the cosmos?
Well, I said I would have to say I don't know to some of your questions, and in a way, this is one. I mean, I can describe sort of what happened, and it's a good story.
Let's
but
hear
I
it.
don't, I don't know exactly. But
Okay.
I had polio when I was 3 years old. I still have a walk with a limp, have a cane, that sort of thing. It's the last year before the vaccines came out, and that gave me I was sick for much of my childhood, lots of surgeries, lots of time in the hospital and in bed recovering. I read a lot because I couldn't do other things, and sort of put me off on a sort of more intellectual curiosity track, perhaps. But the other nice story is that I grew up in the South. It was very hot and humid in the summer. Very uncomfortable. We didn't have air conditioning, very uncomfortable to be in, casts and orthopedic appliances, had a lot of trouble sleeping. Right. So my mother had this was like, when I was 6, 7, 8 years old, 5, 4, something in there. My mother would take me outside at night and lay me on a blanket looking up at the sky and talk to me about the stars and stuff until I fell asleep. And according to her, I started saying I wanted to be an astronomer. I doubt I even knew what that word, but that's when I was about 6 years old. And I, for my whole, as long as I remember, that's what I wanted to do. And I was fascinated with the sky. I briefly flirted with going into artificial intelligence because I took some course from Marvin Minsky when I was an undergraduate at MIT. He's one of the fathers of AI, as they say. And I thought about going into that. If I had, I would probably, my financial worth would probably be 10 or 100 times greater because everybody I know that went into computer science at MIT and at that time, which I was class of 71. So just before the personal computer Silicon Valley, they were all very well positioned. But anyway, I don't regret it. But
good save.
Good
and
mother.
Good era to be born in because
and a smart mother to put him outside for the what a beautiful
to inspire
story. Yeah. Definitely.
And I came along just at the right time when the space race with the Russians suddenly put a lot of resources, a lot of the country's attention went to science education and things like that. So I had the I benefited from that emphasis on science education that came along in the late 50s, early 60s.
Do you continue to feel inspired and by in this field as you see more and more information? I mean, aside from the fact that you hold the status of your being a professor and being at the university, you personally, before you dance off the planet, what really excites you? What do you see with this going, for yourself?
Well, for some reason, I don't know, it must be some psychological defect. I've always liked working on problems that seem so hard and so difficult that I didn't think I would ever get the answer. I don't like having the answers in some ways. I like working on them. And that's why for the most of my career, I was a cosmologist working on the large scale structure, the universe, the origin, the nature of large scale structure. You read some of the things that interested me. And in the late 90s and early 2000s, the answers to most of the questions that, motivated me early in my scientific career, say when I was a graduate student, we finally got answers to my great surprise. We have now pretty good answers about things like the age of the universe and what its composition is between the dark energy and dark matter and ordinary matter and all of that. So I kind of drifted out of that. That's when I sort of drifted into astrobiology, because that has a lot of I like big questions that are hard to answer for some perverse. And to answer your question, and you mentioned it as a sort of final frontier, I agree in many ways. I would love to have some better insight into the nature of consciousness. It's a really, really hard problem because it's intrinsically subjective. And, there's this old problem, solipsism, of how do we even know that other people are conscious and have, any inner awareness of their existence. And it's, there's lots of reasons to think they do, but you can't really demonstrate it. It's like the philosophers worry about this sort of thing a lot. Like, if I see the color red, you see the color red, are we having the same qualia,
experience,
same internal experience, or do I have the experience that you have when you see green, when I see red, and vice versa, or something? You just have no access to checking those things. A few years ago, a number of colleagues and I, including Professor Pete Hutt from the Institute for Advanced Study, whom I would recommend if you're looking for other people to interview in this book, co-founded with, I think there were a group of 7 of us originally, a thing called Y House, where we tried to have an interdisciplinary approach to consciousness. It has sort of died for lack of funding since, but that's the big problem that probably most interests me. And the origin of life, I would name as another one, where I think we have all sorts of theories of the origin of life, and but very, very hard to say anything confidently about what actually happened on Earth, never mind what might happen elsewhere. There we have a little better chance, because if we find life outside the Earth, that will at least tell us that it's probably not one of these statistical fluke things. It's probably
getting back to the statistics and getting back to the origin of life and the big picture. This emerging idea, this new story of the universe that is emerging, that it is so improbably, statistically improbable that all the laws of physics come together, that they do to even support life, and that the chances are that if this was different and that was different, it just wouldn't exist. You wouldn't have a universe. And that if it's here, if the laws of physics are here and supporting life, then why not all over the cosmos? Not only that, but that the birth of the stars are ancestral to us. There's no chance that we couldn't evolve the way that we did. Everything was set up to become conscious life, and that life just wants to evolve consciousness to reflect itself and celebrate itself. There's some scientists getting together and saying, you take all the disciplines and put it together, and everything's pushing it to evolve into consciousness. And we're just a part of we're just one cell in this entire body of life. How do you respond to that idea? It's a growing idea and an exciting idea. And of course, we want that to be true.
Yes, it's, the sort of issue that you're referring to, I think, I associate with this thing called the Anthropic Principle, which is the claim that many things it's an attempt to explain something, namely why the universe is hospitable to life, why life develops.
Yes. Yeah.
Yeah, why we exist, or it's even why anything exists, by observing that if it wasn't, we wouldn't be here to ask the question.
Yeah.
So it's
so
sort
it must
of,
be. Yeah.
So it must be. In other words, our asking the question of why the universe is hospitable to life is
already answered.
Only possible in a universe that has life. So asking the question implies that you're living in such a universe. That's various versions of that are called the Anthropic Principle. I once presented this idea to the members of the philosophy department at Princeton, and they hated it. They tore it to shreds.
Okay.
By pointing out that it's not really, it's true, it's a tautology, but it's not an answer to the question. And it would be like, I haven't seen a coffee or tea cup there in your picture, but suppose you were drinking a cup of tea, and I said to you, "Why are you drinking that cup of tea?" And you replied, "Well, if I wasn't drinking a cup of tea, you wouldn't have asked me the question." That's true, but that's not why you're drinking the cup of tea. You're drinking the cup of tea because you like tea, or because you're thirsty, or whatever. And to some extent, I think those sort of answers about why is the universe hospitable to life, to say, well, it has to be, otherwise we wouldn't be asking, are sort of like that sort of rather facile and silly comment I just made about a cup of tea.
Well, could we
But
rephrase the question and say, we're here because of a huge number of systems coming together that are improbable?
yeah, there's some deep deep puzzles, or even paradoxes almost, about the origin of complexity in the universe. If you want me to give a
Yeah.
really crazy speculation,
Okay. Yeah.
there's as you probably know, there's 3 laws of thermodynamics, and the famous second law says that the disorder in a system, a closed finite system, always increases. That's the second law of thermodynamics, that says things are always moving towards equilibrium. But on many different scales, many different contexts, I think this is sort of what you were saying, many different disciplines, we see the universe producing increasing complexity, which is going in the wrong direction, the opposite direction. How can that be? Well, we do understand that for some part of the universe to become more complex, like what's going on Earth is now much more complex than what was going on Earth before life evolved.
But we see equal episodes of blowing it all up and destruction and chaos, too.
Right. And on average, things are getting more disordered, but locally they can become more ordered.
Yeah. Which neighborhood are you in? Yeah.
Right. It's a sort of local phenomenon. So I've speculated, and if I were a better physicist, I would try to see if I could derive it or something. But maybe there's a 4th law of thermodynamics that says in a system which is on average becoming more disordered, there's some tendency for the spread of order in
Keep the whole thing in balance.
to spread out. So some parts of it are always going to be becoming more ordered. The difference in a degree of structure and order and the degree of chaos in different pieces of a system has to increase. That seems to actually happen.
Like a dance. Yeah.
There's systems in which it doesn't seem to happen, but in many systems it does. Even if you look at human civilizations and things, the most structured civilizations are more structured than the least, and so on, and spreading out. So maybe there's some fundamental tendency in the laws of nature for
the roller coaster ride. Yeah.
For complexity to arise. And that's another area I would love to know more about. But
we're just enjoying a phase, and it's not going to last forever. Yeah.
It's also possible that question of why the universe is hospitable for life, or why it even exists, is a question that lies outside the reach of science. If I can quote Feynman yet again, in a way, science is just a tool which is extremely powerful for answering certain classes of questions. But its own, and many scientists and many people who are devoted to, let's say, rational inquiry, to use a more general term, are convinced that all knowledge must be within the reach of objective inquiry or science. I rather think otherwise. I think there are very valid questions that science is powerless to address, just as there are questions. It's sort of a tool that lets you answer questions about topics where linear thinking and hypothesis testing, experimental hypothesis testing and deductive reasoning and things work. I mentioned Feynman because I was a grad student at Caltech when he was a professor there, and he had a custom on Friday afternoons of having beers with the graduate students, and on the condition that no faculty or anything allowed. And his condition was that we could talk about absolutely anything but science. So, politics, music, relationships, you name it, anything, art. But occasionally he could be lured into conversations about science. And he had this wonderful metaphor called which could be referred to as the child and the chess masters. And I actually have a whole lecture. I was sort of inspired by his comments on that, but and I could go on at great length about it. But his basic point was, is imagine a very intelligent child, say 10, 12 years old, something like that, watching two chess masters play chess over and over again. And the child's fascinated and tries to learn the game of chess. And in fact, can eventually keep records and figure out the whole game. There's parts of it that are straightforward, like how the different pieces move. There are parts of it that you have to have a flash of insight, like, what is checkmate? There's parts of it where there are very strange moves like castling or capturing en passant and things that, are sort of anomalies. All of that they could figure out. The child could figure out, but she could even become a great chess player. But Feynman would say, I wish I could do his Brooklyn accent, do an imitation of his accent, but I can't. But anyway, he said, then you come and you ask her, why is the chessboard 8 by 8 and not 10 by 10? And, why are they playing this game? And how do they feel about it? And where did it come from? And he would say, he used to say, you spoiled her fun and now she's going to cry. Because, and which is what scientists often do basically when confronted with questions like, why is there
Spoil our fun? You can't ask those.
yeah, that's not a real question, they'll say, or they'll get angry or upset, but basically,
or pretend that they know.
Yes, or pretend that they know, right? But basically, there are, science is a hammer, lots of problems are nails. There are people who are very, very good with that hammer and they love nails, but there are also screws in the world. And you try to put in a screw with a hammer and it doesn't go that well. So some of the questions that we would love to know the answer to, and which may really have answers, may simply not be accessible using the techniques of, Galilean experimental reductive science.
There are many tools in our toolbox. Let's use them all. And that's one way that, one reason why we are really fond of ancestral wisdom, because it was using a different set of tools, pondering these same questions and different avenues to answer them. And I think, like, I'm an inclusionist. I want to see it all. I'm not going to weigh one better than the other. I just want to see it all.
The ancestral view of the cosmos and from their perspective and how they were able to.
And the different languages. This is why we have the arts and the sciences represented here. And I appreciate that you have a foot, that you're still a hippie. And you have a foot in that realm still. I think that makes you a much better scientist.
Well, I think it's helpful, but it's at least comforting. But I do, again, let me mention Pete Hutt, who has a very sophisticated view of what he calls ways of knowing. And that includes the wisdom traditions of various ancient cultures or current cultures and scientific ways of knowing. He organized years ago a set of meetings on ways of knowing in summer schools and stuff. It's a very useful, I think, approach to ask, what would be the most effective tool for approaching this question.
Well, in a lot of questions, I'm fond of the theory of panspermia after talking with Chandra Wickramasinghe, who worked with Fred Hoyle and interviewed him. And I thought, what a great theory, that life could arise and then it could be spread on the backs of comets and meteors from galaxy to galaxy, and that it would find and has all the codes within it to adapt to whatever conditions it finds. And it really, I love that theory. I asked you about it, and you said, we're not fond of it, but it doesn't mean it's not true, right? So I appreciate that. Just because it's improbable doesn't mean it's not true. Yeah. So.
Well, that's an example again of Bayesian statistics. I think is something that strikes most people as a priori unlikely. But you did mention, and again, you can update your understanding or views of these things with new evidence. And you mentioned extremophiles, and a few decades back, I guess extremophiles as a concept came about, I want to say in the 80s or maybe mid 70s, fairly recently, mostly based on, initially based on discoveries made in the hot springs in Yellowstone National Park, where they discovered organisms living in conditions that were thought to be impossible for life to survive, and it adapted. And today there's a huge panoply of different types of extremophiles, that creatures that live in
the deep sea ocean vents and the deep vents in the earth where the oil is made and compressed and under pressure and all sorts of conditions.
Everything very
in
hot,
the ice of the Arctic.
Very salty, very dry, very acidic, very base, the opposite of acidic, very high radioactivity. They're organisms that can live inside nuclear reactors
and help break down that waste. I like what Michael Crichton said: life will find a way.
And that encourages one to think that panspermia might have some chance of being true. I think it's no longer considered too wild a hypothesis on interplanetary scales, like between, say, Mars and Earth. We know that there are meteors that land on Earth that were once on the Martian surface, and presumably there are meteors that land on Mars that were once part of the Earth's surface, and they probably spend only a few million years in interplanetary space on average before they impact, and maybe something could survive in those. Across interstellar distances seems a bit, if you do the numbers, there's nothing wrong with the idea, but if you do the numbers, it doesn't look too good. An interesting hypothesis that came up not so long back, the two authors, Fred Adams and David Spergel, Tony and I were talking before the show, both know Dave Spergel, for example, suggested that life might spread between different stellar systems, not currently, but when the stars form and cluster, very
and they were closer together,
much closer together, and they've written a paper about that, and which looks considerably more promising. It is an active area, an active possibility. I think it doesn't really change the origin of life question that much. It means that maybe it didn't originate on Earth, but you still have to explain this big gap that we talked about before between the complexity of living systems and the complexity of, or the lack of complexity in abiotic systems. It just says it happened somewhere else.
And what do you think is in? I mean, it's hard enough to decipher the 5% of the universe that we can see and detect. What do you think the other 95% holds of dark matter and dark energy? Consciousness, life, complexity, different particles, different laws. What's going on there, do you think?
Well,
guess.
Yeah, we don't know, obviously. The dark matter is not nearly as mysterious in principle or in theory as the dark energy. The dark energy is, people have fundamental physicists who know, much more profound physicists than I am or ever could imagine being, consider it the most difficult or most puzzling unsolved problem in physics. My nomination would still go to consciousness, and maybe time. But
it's interesting.
uh, yeah, I could say more about that in a minute, but the dark energy really is extremely hard to understand and makes virtually no sense. And I think there's no plausible explanation of why roughly 70% of the equivalent mass density in the universe is in this dark energy form. Calling it dark energy is kind of my my
Misnomer.
my evil twin, Mike Turner from the University of Chicago. We call each other that. Gave it that name, dark energy, but it's not a
Really?
great name
Oh.
for it. I mean, all energy is dark in a sense, but what the dark energy is a pressure. A way of describing is that it's a pressure exerted by the vacuum. So if you imagine a box that's empty of everything, there's
Okay.
a pressure pushing outward on that box for some reason, even though there's nothing in it,
Hmm.
that corresponds to that dark energy. And if you make the box bigger, the pressure is greater. Um,
Okay. Makes sense.
and
That's logical.
but why the only the only sort of plausible types of physical theories that explain that predict a dark energy that's a sort of 120 orders of magnitude, one followed by 120 zeros,
Okay.
times bigger than what we observe. So the two values you could sort of understand are zero, that would make the most sense, or this huge number, which would be due to quantum effects.
Hmm.
But what we actually see is, a small but significant dark energy, significant on the cosmic scale. Um, anyway, I think anybody who figures that one out is entitled to 10 Nobel Prizes, I think, by the usual standards. So I really don't have any notion of what could be going on there. The dark matter, on the other hand, there's a lot of possibilities for what it could be that wouldn't be too big a disturbance to known physics, various sorts of particles.
Hmm.
In those models, it's very simple stuff, to try to answer your question. It's not something that would
Upset the apple cart too much?
and it wouldn't have much complexity. It would be basically just a gravitating fluid that helps hold things together. It would not be
Mm-hmm.
the home of complexity or life or something. But that's not to say that it isn't. It was just that our best models of it have no indication of it, being.
What it does do, though, is it tells us something about our place in the universe and that we're not seeing the big picture and we're not equipped to see the big picture. And so a lot of this is just going to be guesswork, like assuming you know something about the wind because you see it blowing the shafts of wheat in the field. You can
Oh,
see its
that's a great
effect, but you're
metaphor.
not seeing the substance.
Oh,
So,
I love that wind and blowing the wheat or the leaves or something. I'm going to steal that if it's okay,
oh,
because
please, I'm honored. Yeah.
that's exactly how we know about the dark matter. We see its gravitational effects, but we don't see it.
Mm-hmm.
We see the forces it employs. So, uh, there's a vast literature on this, but my personal guess is that if I had to bet, I would bet on some sort of elementary particle, often called a WIMP, which is a weakly interacting massive particle. It's just an acronym. Uh, that is part of the normal particle physics. But you're quite right. I mean, the majority of the material mass energy density of the universe is in this dark energy, which is not even matter. The majority of the matter is in dark matter, which is not ordinary atoms and things. The majority of ordinary matter is in hydrogen and helium. And we're basically made of the residue of the residue of the residue of the stuff of the universe. We're kind of
Mm-hmm.
the tiny contaminant on the contaminant, that sort of thing. It's a
I would say we're the recycled material, making good use of it to regenerate out of the compost, right? So, two questions: Galileo, Newton, Einsteinian relativity, quantum. What new physics is on the horizon? And consciousness. Where does consciousness lay in all of this for you
well, it's
and this dark energy?
consciousness is a real puzzle for physics, because as far as we can tell, or as far as at least I have ever been able to understand, it's associated with matter. It's associated with, in particular, with, the matter inside your head.
The gray matter.
Yeah, the brain. Because if something physical happens to your brain, if you have a brain trauma from a stroke or an accident, or if you ingest certain psychotropic chemicals, drugs, your consciousness changes. And you can even, we can do fMRI and look at what parts of your brain are active, and that will tell us, that would correlate, let's say, with the nature of your consciousness, like whether you're asleep or not, or, whether you're thinking about, actually different parts of your brain are active if you were, say, doing your taxes and doing a lot of mathematical thinking, or if you were singing or talking. There are things that happen in your gray matter in your skull are correlated with your consciousness.
And to support your intent to what you want to do. Yeah.
And so there's clearly some connection between the material universe. And similarly, if I said, please raise your right arm, then thank you. And that's an example of it going the other way. You became conscious. I had the thought of doing that. I caused myself to say that. You heard it. It changed your consciousness. And something material happened when you raised your arm. So there's good evidence that there's a connection between consciousness and the physical universe. Yet nowhere in any law of physics, nowhere in anything we know about the fundamental physics of how the universe operates, is there the slightest hint of anything like consciousness. You could describe everything we think that goes on in the physical world according to the basic laws of quantum mechanics and general relativity and so on. And those are just equations that relate things like positions and masses and speeds and motions and many other physical properties. But our whole mathematical description of the universe
inadequate to the task as thus far.
Requires no consciousness. So you could imagine somehow a complete physical description of the universe would be almost impossible to derive any hint that consciousness was there. There's also no hint that that the present is here, that things are. This is, I mentioned time before. We experience existence as being divided into the past and the future by some instant we call the present. No hint of that in physics either.
So time mathematically defies our personal experience of it. It's far beyond what we know.
Yeah, I mean, time, just like there's indications of connections between consciousness and matter, time is an integral, excuse the wordplay for the mathematical, part of our laws of physics. They're all second order differential equations with respect to time. So time, like we measure on clocks, we can measure it very accurately, and that sort of time appears in physics. But the time we experience, the time that divides the past from the future, is not really apparent. You wouldn't know that there was such a thing just by looking at the laws of physics. So both the nature of experience time and consciousness are sort of holes, and someone I think called them holes in the heart of physics.
So if you ever want a unified theory for physics, you're going to have to incorporate time and consciousness and this dark energy, this dark matter. You're going to have to, we know it's there. It's got to be included.
Yeah, I think dark energy and dark matter are easier. They're at least physical things that we can measure. The cognitive scientist, the philosopher Susan Schneider, and I wrote a paper on a possible test for whether an artificial intelligence was conscious.
Okay.
And I feel like one of the most interesting things about artificial intelligence to me, is not that it might drive the car or something, or shop for groceries or all those things it's supposed to do for us, or that it will take over the world and replace us, or go to the stars for us, is that it might shed some light on the nature of consciousness. There's maybe a hope that we could.
Under what
somehow,
circumstances does it arise? How
yeah,
complex does the organism need to be? What's
exactly.
self-referential? Yeah.
What properties? Of course, we have to be able to somehow tell if it's conscious, and we could just rely on it we could ask it the question, but that's a direction which I would love to see work go in. I don't think I'll be around long enough to get answers to that, but or at least not in this incarnation. But it may well be that we can build systems that have some degree of consciousness. And in fact, we do build systems that have consciousness that we're called babies, that grow up into people. But we might be able to build ones that we understand better than we understand.
Well,
babies.
I have to ask, who's really doing the building there?
Yeah.
Yeah. I think we're just the carrier system. But let's go to some questions. I know, Tony, let's bring you back. And thank you. Yeah.
Okay, let's see. Okay, and so many things. It's feeding from a fire hydrant right now. It's quite amazing. On complexity, I'm wondering if you found any particularly evocative readings. I've asked John Mather that, and he says he doesn't like any of the books. But I'm wondering if you found something that you like or that you'd recommend.
Well, there's a very good book, I think, by Roger Penrose called The Emperor's New Mind, I believe it's called, and which goes into many things, but certainly does talk about complexities. Well, it talks about nearly everything in a way, but it talks about complexity and the nature of consciousness. I don't agree with. I don't find his hypothesis for the nature of consciousness particularly plausible or compelling, but the book itself is a wonderful discussion. On complexity more specifically, there's something called Langton's ant, A-N-T. It's a man's name, Chris Langton, Langton. And Langton's ant is not an ant at all. That's just a name for a sort of cellular automaton, that is a sort of computer system, that is an extremely simple deterministic system that, and really simple, I mean, just, I could describe the rigorous rules by which it operates in, a few sentences. And it displays complex behavior. So I don't know that there's a book about it, but if you look up literature on Langton's ant, and there's also something called a generalized Langton's ant called a glant, G-L-A-N-T. That poses some deep issues and perhaps sheds some light on them. I think it actually demonstrates that reductionism is intrinsically, this is a controversial claim, but I have claimed that it demonstrates that reductionism is demonstrably incomplete. That is to say, you can understand everything about a system at a reductionist level because it's an artificial system. You created it, you postulated it, and there's still questions about it you can't answer, even knowing exactly how it works.
Well, like a tiny little ant, where's the brain in that ant to be connected to the whole hive and coordinate as one? Yeah.
It's not actually an ant. It's it's a computer system, but it's the equivalent. Let me whack.
They're referring to an ant
for a moment. It's the equivalent of a 4-state Turing machine, which means that there are unanswerable questions about it by one of Turing's theorems. But the amazing thing about it is that it's just so dead simple, and it's basic operation and yet displays such complex behavior.
Yeah.
It's very interesting. Well, I'll definitely look into that. And I wonder if you would comment a little bit more on Avi Loeb and what the Galileo experiment may be able to achieve. What are the metrics?
Well, I should say that the Galileo experiment, or project, not experiment, project,
Project, I'm sorry.
was instigated as a result of sort of two things. First was the observations of the interstellar object Oumuamua, which passed through the solar system briefly, and I guess it was 2017, and on an unbound orbit, and showed a lot of odd properties, which Avi and his students have postulated might be due to it being an artifact of some extraterrestrial civilization, something perhaps like a light sail. And perhaps somewhat more famously and controversially, last June, as you may know, in response to direction from the Congress, the Office of the Director of National Intelligence issued a report which basically said that what is now called UAP, unidentified aerial phenomena, used to be called UFOs, unidentified flying object, that the government data, the military data, indicate that they are real in the sense that something is there, some sort of object is there, and that their nature and identity is unknown. And as you just within this last week, the president signed a bill passed that funded the U.S. defense budget, but included a provision that the government is now required to establish a central coordinating office for investigating these UAPs. So
very significant week for the cosmos.
Yeah.
Yeah.
so
Objects in the sky, I keep on thinking that the results of the Rubin telescope, which will cover the entire sky twice a week, if I remember correctly, that access to that data or the variable interpretation, clearly things will show up.
yeah, well, especially there's sort of two branches of the Galileo project. One is to look for objects similar to Oumuamua passing through the solar system, which should indeed show up in considerable numbers in the Rubin telescope survey. Perhaps these UAPs, which seem to be more like these things that buzz Navy pilots and stuff like that. But the idea of the Galileo project on the latter is to build well understood, calibrated scientific instruments that will get much better data on these objects, whatever they are, and try to take a very open scientific, by scientific I mean everything will be public, there'll be no classified data, the data will be made available to everyone, the analyses that we do will be published and looked at through the normal publication of scientific results thing. Basically, the Galileo project is of the opinion, is a group of scientists and engineers and others who are, I'm very impressed by the quality. And Alan Stern is even a member of the group, for example, and many other very distinguished people.
Yeah.
That will take the whole phenomena seriously enough to do an open and objective and unbiased investigation of it. The project itself is still in very early stages, designing instrumentation and testing equipment and debating, should we have a very large number of less capable observing stations or a smaller number of more capable ones, and so on and so forth. It's the project is only about 6 months old, and we certainly don't have any data yet. And are
I'm sure. I'm just wondering about the probabilities of the incidence of these phenomena and the number of cameras or devices that one would have to record them. And of course, one of the enigmas is that about 99% of all images that have appeared are fuzzy, and that makes them questionable. So I'm sure that there has to be a certain sharpness, incisiveness to what's being done to make them useful.
Well, that's yes, exactly. A major unknown is, for any given system we might deploy, how often would it see something interesting? And if it's once a year, that's maybe okay. If it's once every 10,000 years, not so good. And also the question of how good an image quality you would need to actually say something definitive. And those are all issues we're thinking about and debating, and there's various working groups and so on and so forth. It's
Laura, would you comment at all about the local situation and the propensity for seeing things?
Oh,
Okay.
uh,
Well, go ahead.
I missed part of that. What was the question again?
Oh.
I asked Laura if she would comment on the
Okay.
story she had told me about Sedona.
Yeah,
So,
okay. So I had shared with Tony that I was invited to go to a park here, and there was a group that hands out military issue quality binoculars where you pick up light, right? It looks like a green screen and you can see light. You look at the night sky. No, I really experienced this. So you look at the night sky and you see the stars, maybe some planes with blinking lights. But you put these on, and now suddenly you start seeing little dots traveling in twos and singles and threes. And then the guide was, oh, here's a laser. I'm going to put a laser in your hand. But, and this was interesting. He said, don't shine it on the light, because if it's a plane and a military plane that is going in stealth mode, you do not want to shine a laser light into the pilot's eyes.
Well,
These could be military planes, but they were behaving very oddly. And so, and I'm thinking, okay, so, it's 8 p.m. at night. It was a dark sky. The satellites these are not satellites. Or so they say, that the orbits, whatever. But we were seeing, constantly little lights, and they'd be doing this. And I'm like, okay, I don't know what they are. I'm just reporting it to Tony. Tony, when you come visit, we've got to go out with these military lights. So that was it. So I don't know,
well,
but I experienced it.
I think that you see
And
them
with multiple
routinely.
people. Yeah.
what'd you
I
say,
think
Tony?
you see them routinely, that tours are scheduled in advance.
Yes, these people come out
Yeah.
and they charge so much an hour,
They cost-
and then the next group is going to come in, and you can only last with those things in your eyes for an hour, because it really brings in a lot of light into your eyes and you get fatigued. And they guaranteed, yep, we saw them.
I went on eBay to see if you could buy some, and they're like thousands of dollars.
Oh yeah, no, this,
Ed, I wonder what you'd say about this, and I have a question for you after that.
yeah.
Well, I don't know enough about it to say much, but the sort of thrust of the Galileo project, we hope, will be to get away from sort of anecdotal things like that.
Right.
Yes,
I
thank
know.
you.
Yeah.
Things where you have to depend on
Eyewitness reports.
eyewitness reports that can't be replicated and things like that, and where you have very calibrated instruments. Like, it might be interesting to take your what sound like infrared goggles or binoculars
Whatever they were.
indoors and point them at a blank wall and see if you see any spots moving around. They could be
Oh, interesting. But they also said, don't shine it on a light. Don't shine it down where you see a car headlight or something, because you'll
Hurt your eyeballs.
well,
I see.
that too,
Yeah,
and the
yeah, yeah.
binoculars.
well.
So,
Anyway, you
Yeah.
want to. What we hope to do in the Galileo project is to get data where we have,
unassailable data. Yeah.
Well,
calibrate
one
know what an airplane looks like to this
There's a
instrument.
better tool for that.
one of the things that interests me is that this is a regular phenomenon there, and this might be a logical place, a number of logical places to take instruments where the instrument and the phenomena intersect, as opposed to taking it where nobody has ever seen anything.
Don't look for your keys under the headlight when you've lost the keys over here.
But that's not the point here.
Phenomenon.
So,
Yeah.
Ed, have you ever seen something in the sky that you did not understand?
Yes, but I don't think I've ever seen any. I mean, I've seen things, I just don't know what they are. I've never seen anything that that I would felt to me like something that was likely to be ununderstandable. I mean, a point of light moving in the sky could be a lot of things. But,
Exactly.
If I may, once when observing at Kitt Peak on the westmost telescope, Being trained as an observational astronomer, I'd go and look at the sky every 20 minutes or so, step outside the dome. And to the west, there was a constellation of 7 lights. They were moving in a very strange way. They were moving like this, and then down, and then over, and then up. And I had no idea what they were. Uh, but I've read other descriptions of people who've seen the 7 lights in the western deserts, and that's the one enigma I truly have, of having seen something I have no good explanation for.
Yeah, there's a vast literature
Join
of
the government.
things that people have seen and reported.
Yeah.
Some are quite hard, I mean, you end up at some point in just wondering whether, I mean, it's a big jump from seeing something you don't understand to saying they're extraterrestrial.
What it is.
Right.
Yeah.
Absolutely.
And coming back to Avi Loeb, I mean, his energy is contagious. I mean, this guy is exciting. When he speaks and shares his story, and I just like the way that he approached the idea that, hey, I'm at this level. No one can, no one's going to make me shut up. I'm going to say what I think and just ask questions. And I think
to celebrate the questions.
Yeah, and I think that was what was really refreshing, and I enjoyed that. And so I'm glad this project is underway. And
just because something may be unpopular doesn't mean it's wrong.
Right.
Yeah, I like that.
Yeah, so he's a good team member to be working with, I imagine.
Those are some fun meetings you go to. Yeah.
Yeah, I've known Avi for over 30 years, and we've collaborated on a lot of things. We tend to see many things in similar ways.
I want to know, when has the government knocked on your door and said, well, gentlemen, this might be getting into national security issues or global security issues? Or is that just too much the trope on the sci-fi movies? But
to my knowledge, that has not happened so far.
yeah. And so what do you do? I mean, suppose you find evidence, you release it to the media, you have other telescopes around the world verify it or look at it, or other scientists. What's the procedure if you find something that goes,
Well, it probably depends on whether you have tenure or not. I'll say that first.
That's what Arby said.
Oh, dear. And then what are the implications to society, right?
We actually have a subgroup that is thinking about the societal impacts of possible discovery. Yeah. And, so we're trying to address those questions. I think these sort of discussions will be much more interesting in a year or so when we've actually got some of our original thinking done. We're still debating a lot of this stuff internally. But to answer the first question, what we intend to do is publish papers in the open scientific literature.
Sure.
And if we'd have to talk to an attorney to see, whether the government could prevent us from doing that in some situation or another. I was actually director of the Apache Point Observatory 3.5 meter telescope back in the 90s and early 2000s, and the observatory, which is in White Mountains overlooking Alamogordo, New Mexico, overlooks Holloman Air Force Base, where at that time a squadron, or I don't know what the correct military term is, was one of the bases that the U.S. operated F-117 stealth fighters. It was the first stealth aircraft, I believe, deployed by the Air Force, and they used to overfly the observatory at night on their practice runs and stuff. And we had a lot of discussions with the military about dangers of illuminating them with our lasers, or of getting inadvertent data on them that might be, classified or things like that. And there is some interface between classified government activities and public observations and investigations that has to be navigated. I don't think I can say anything except it's complicated and potentially problematic. But to date, there's been no as far as I'm aware. I mean, maybe somebody's been in touch with Avi I haven't heard about, but as far as I'm aware of it.
Well, or if it happens in a different country, does that country have some sort of, hey, it happened in our skies, we own this info, or something, or a piece of material, who collects the material and gets to analyze it? if you find an object, if Oumuamua, which might have been a sail devised by some other civilization, falls to Earth and it's an object, what who
owns it?
who gets first dibs on it? I don't know. Lots of interesting, complicated questions.
Yeah.
So,
Politics.
are you prepared personally, Ed, if there's demonstrable evidence that we're not alone?
He went to Woodstock. He can make that leap.
Well, one thing I wonder about, here's an out of the box thought. Public opinion surveys show that in pretty much every first world country, every wealthy country on Earth, whether they're in East Asia or Europe or the U.S. or North America, I should say, Australia, you name it, roughly 30% of the public, give or take, believes that we are being visited by interstellar spacecraft, piloted or sent by extraterrestrial civilizations. They think that's true already.
Right.
That's a
They'll
pretty
say, "I knew it all
part of the
along."
public.
Yeah.
I wonder what that implies. And they pretty much are just ordinary people going about their ordinary lives. It hasn't traumatized or it hasn't really had much effect. It's just like the idea that there's this great line in Sherlock Holmes somewhere where Sherlock Holmes says something about the sun going around the Earth, and Watson corrects him and says, no. The Earth goes around the sun, and Holmes says, well, what difference does it make? And I don't know whether, obviously it'd be huge news if UAPs were shown to be visiting extraterrestrials, and I would think it would sort of change everything. But maybe a lot of people, as long
Maybe
as
we're
they,
already there.
would sort of shrug and say, lots of people think we know there's life on Mars already, although we don't. But, it doesn't bother them too much, or it doesn't affect them too much. So
I want to say that ancient populations, many of them, we hear indicators that they already are. We've talked to a woman in Peru who says that her ancestors, there's a long tradition that they have been, no big deal. Native Americans, you can talk to elders and they say, oh yeah.
We came
and
from.
And we knew Ipu Piara, whose traditional story of the Uruwe Wawa tribe out of Amazonian Brazil says, we call ourselves the Star People. Our legend says the clamshell landed, opened, and out stepped our people. You can take it as a mythic, which I do. But, there's been that. So it's not just advanced Western societies, but it's a very old story. Yeah.
It may be, maybe even more common in other societies. I don't know. To some extent, I think it's tied to, if I can get way out of my box and make a religious comment, the Levantine religions, the religions that came out of the Levant, which are Judaism, Islam, Christianity, have the same metaphysics, that the world is divided, reality is sort of divided into a spiritual holy realm and a mundane earthly realm. And people are unique in that they connect the two in some way or another. They're expected to live in the mundane realm by the laws of the spiritual realm, or they move from one to the other when they're die or born. And they all give humanity a special place. You can see it in the sort. Many other cultures have religions where humans are simply seen as a part of the natural world, not different than or more important than or special in any particular way. Buddhism certainly has that sort of structure. And in the intellectual values, cultural venue of cultures that are heavily influenced by one of these religions or another, they're not, some are more, make it easier to see extraterrestrials as fitting naturally into the scheme than one in which I was part of a study funded by the Templeton Foundation and NASA about the societal implications of astrobiology, and it was primarily from a Christian perspective on the religious side, but there were other world religions represented. But it seemed that the idea of intelligent extraterrestrial life, we had very distinguished theologians, Christian theologians and others around the world, but there was a lot of issues that came up in Christianity, like, would aliens need to be saved, or could they be baptized, or would Christ need to come to every inhabited world to bring salvation? And there were issues that came up.
What are angels, right? What are angels and the Holy Spirit and spirits? Yeah.
But in some of the other religious traditions, there didn't really seem to be any difficulty fitting in that idea. It didn't raise any extra
It's
questions.
one creator overall.
Yeah, they hadn't elevated humanity and their metaphysics to any special status. So I've forgotten why.
As ancient cultures did. We're part of one vast ecosystem that goes beyond. Yeah. Brian Tucker, you have something to add to this, I'm sure.
Yeah, this is really fascinating today. Thank you for having this talk, and Ed for joining Kuyamunga. I was curious about your reference to the ways of knowing, and that science may have there's maybe certain questions that are outside of that domain. So I was wondering, what was that reference you made? And again, the place of indigenous wisdom alongside science, where you see good examples of this coming to bear fruit.
Well, this view of ways of knowing is really my friend and colleague's Pete's Hut. So I'm only sort of speaking in a derivative sense, but ways of knowing would include, for instance, meditation as a way of gaining insight. Might include prayer and revelation in some traditions. Could involve, but not necessarily religious, artistic investigations. I have a friend who's a somewhat well-known contemporary artist who investigates questions about the consequences of trauma in people's lives and values with works of art that can be thought of as a way of gaining insight or knowing something.
I knew you were one of us. Yeah.
To some extent, it's a matter of what you mean by knowing. I think there's a tendency for scientists and science to define knowing in such a way that it excludes knowing something that you don't know scientifically, that they sort of in the meaning of word knowing. But I would go back almost to the child and the chess masters and so on. Analogy. There may be answers to questions that the child about chess that the child can't find out by her techniques of observing people playing chess, but that doesn't mean that she might not find it out by reading a book about the history of chess or something like that.
Or you could say that we weren't built with all these other additional ways of knowing if they weren't meant to be used and to fill out the human experience, right? You could say that.
Yeah, I mean, there's sort of aesthetic and truths and moral truths and things that in some sense seem to be self-evident. I mean, I don't consider myself remotely qualified to get too substantive about such things, but I think it is reasonable. In Zen Buddhism, which I know a little bit about, there are what amount to courses of study, sometimes called koan, K-O-A-N, koan study, which are not very different from the way we teach, in a sense, in the way we teach mathematics. Something there's like books with a set of problems or koans that you work through, and it's very systematic, and you work under the guidance of the teacher and everything, and purportedly, given enough commitment and determination from anyone, can kind of go through this learning process, and at the end they know something about reality that they didn't know going into it, and in a way that's been sort of standardized and formalized in almost the same way that we formalize, teaching calculus or something. I don't know if that answers your question, but
Beautifully. That was a
Thank you.
beautiful answer.
Yeah, thank you, Brian.
Yeah. So
And Tony, another comment? I'm leaving you on
I
screen.
would love to hear
because-
from the anthropologist who's here, because this is really,
yeah.
truly an anthropological question as well. But go ahead, Tony.
Well,
Yeah.
no, let's hear from Chris.
Yeah.
I'll see if
I don't want to put you on the
Chris,
spot,
are you
Chris,
available?
but-
Yeah, you put her on the spot. That's okay. Christine?
We usually do. Yeah.
I'm available, but my bandwidth is really bad and I keep having you guys completely freeze. So I want to apologize for not having my camera on.
That's okay. We know you're beautiful.
No. Yeah.
Oh, thank
Paul.
you. Thank you very much. I've enjoyed today's conversation. I think ways of knowing is really important as an anthropologist and different perspectives. And yeah, so I agree with most everything I heard. And I think that we're a long ways from knowing a lot of different things, for sure. Yeah.
So,
Yeah, Chris, would you comment on that in your own experience? How difficult it's been to explore certain areas?
Well, I was agreeing with, if I may call you Ed, earlier,
Please.
that some of my colleagues in anthropology, when you go to do a peer review journal article, they are, what you said earlier, so highly skeptical that sometimes when you're trying to work with Cuyamonga Institute, trying to understand how we might begin to explore spirits, that gets really dicey. I mean, we're definitely an empirical science over in anthropology. So it's always challenging. And we've had so many guests on Cuyamonga, or rather Paul and Laura have so many guests that are starting to say that science as an empirical phenomenon cannot answer everything.
I think that's a fairly common perception from those that are engaged in what I would call rational inquiry, but not exactly science. That is to say,
Right.
they're trying to reach the truth through reason and information, data, but not in exactly the standard scientific method kind of ways. And it's clear that science, from that perspective, science is kind of limited. From inside the natural sciences, I think that's a less common realization. They spend all they spend all of their time hammering nails and kind of forget that there are things that aren't nails.
and I would characterize what we're doing as exploring consciousness in a very age-old practice, in an age-old way.
Right.
And and how you define it is really up to you. No belief systems, but an experiential experiment.
A physiological.
But you were going to say, Ed, sorry.
Yeah, no, that's okay.
Yeah.
I was just going to say, even inside what we regard as science, I think there's an important distinction, which is often made, but sometimes, between sort of exploring available data and doing experiments. It's sometimes the difference between observational work and experimental work. So in astronomy, we can't really do experiments. We just have to take whatever information happens to fall out of the sky and onto our instruments and work with that. And similarly, for example, historians have to take whatever information we have about, there's probably, Alexander the Great had something for breakfast on the day of this battle, and that's a real question that has a real answer. But if it wasn't recorded, there's no way we can find out. And I guess anthropology is probably also in the category of one of these exploratory or observational.
Well, is consciousness
discipline.
going to be, because we don't have the scientific tools to really explore consciousness to that degree, but we do have age-old traditions around the world that has explored consciousness. And do you have a practice to explore consciousness beyond the scientific and theoretical tools that you have employed? Do you have a personal?
Yeah, I think,
needs?
my personal feeling is that that's more promising than the scientific exploration, but the problem's so important and so hard, I would like to
Bring all to bear that.
hit it in every direction we can and see if any synergies popped out. The paper I referred to, that's Susan Schneider and I wrote a while back, was an attempt to come up with a way of a sort of objective evidence about whether consciousness was present in a system by, well, I think I can explain it very quickly. I realize we're
Sure,
almost-
please. Yeah.
But if you take someone who, say, never heard of the idea of reincarnation, and you tell them after you die you get reincarnated in a new body, they understand. I don't whether or not that's true.
Mm-hmm.
They understand that idea instantly, very quickly. You know, or if you make a movie where the mother's consciousness gets transplanted into the teenage daughter and vice versa. There was a movie like that. I forget what it's called.
Yeah.
Everybody gets that instantly. Why do they understand it? Because they have the internal experience of existing apart from their body.
Mm-hmm.
That's they have conscious. They see they perceive. In Buddhism, there's an additional sense, which is your inward perception. You know, a sixth sense. So they perceive that they have some experience of being this physical thing of their body, which is separate from the body itself. Whereas if I said, after you die, your thumb will be reincarnated, you would have no idea. That sounds like incomprehensible nonsense, because you don't experience your thumb as being anything other than your material thumb. And that difference between how you perceive your existence and how you perceive physical objects, including parts of your physical body, is the basis of the test. We called it artificial consciousness test, or ACT. You know, there might be some way of getting hints at whether a system is conscious, depending on how easily it could understand ideas like that, for example.
Mm-hmm. Do you think some of the ancient modes that have really dove into time and consciousness, aren't they worthy of examining, maybe bringing together the ancient wisdom and modern science?
Especially if you're going to tackle the concept of consciousness itself.
Yeah.
You have
what
to
other
look
tools
at
do you
the
have?
human
Look at it all.
history and how we've explored that field.
Yeah.
No, I think that's probably the most promising way to go.
Yeah,
Mm-hmm.
that's it.
Yeah.
It's making contact. It's making contact between that and modern ways of thinking about things that's difficult, I guess.
And what we can conclude is that these questions, are we alone? Who are we? What is our place in the universe? What's the nature of reality? What's the nature of these other realms that show up at times of reality? These are questions that we have been grappling with since we became conscious as a species.
Keeps
isn't
life
it?
interesting.
I mean, this is part of the turf. You're conscious, you start to ask these questions.
It's what keeps
right?
life interesting.
Could I interject a
Keeps us
question?
moving forward. I'm sorry, Tony?
Oh, could I interject another question for Ed?
Please.
Yeah.
Yeah.
Then we'll wrap it up. Good.
Okay, Time Master. Can we go over time?
Yeah,
Just
go
a few
ahead,
more
Tony.
minutes.
Go ahead.
Yes.
Uh, thank you. Ed, one of the things that strikes me as something that can be studied using even mathematical techniques, the same that we use in astrophysics, is the nature of coincidence. And uncanny coincidences happen, at least they happen to me. And they happen very regularly with no explanation whatsoever. I mean, an example, in 1977, I went to a concert in Philadelphia by a New York artist. I discovered that the concert was called Songs from the Hill. I had never been west. It turns out that she had composed the music the prior 2 summers in the town in New Mexico I now live, looking at the hill where my house is. I found that out last year. I mean, things like that happen remarkably regularly, and it's awfully, if you put along the string of probabilities of this happening randomly, it's pretty small.
Mm-hmm. Shows you the role of music in our lives too.
Well, no.
I don't know what to make of that, and I hope you didn't think that I could answer the deep questions we've been talking about today.
I appreciated your perspective on them. I appreciated, what you had to say on that very much.
I just think that this could be a ripe question to look at. That's all.
Yeah. Thank you, Tom.
Yeah. I told one of my friends the sort of things we wanted to talk about, and he said, they've mistaken you for a deity.
Well, Thank you for stepping outside of your what you've considered the comfortable realm, because you've brought out some incredible pieces of data and information and knowledge and
But I
pushed the
also
conversation
feel-
forward. Go
I
ahead.
also feel this is what you scientists get to talk about when you're sitting around over the beer.
Ed says he has a poker group that he gets together with, and that would be a fun
Yeah.
poker game to get in with.
Richard
yeah.
Feynman notwithstanding, I'm glad he set those up, but I think this happens all the time with the scientists. Of course you're going to ponder the big questions. Of course you're going to philosophize, just as all of us do.
Thank you,
Right?
Tony, for
This is the fun
co-hosting.
stuff.
Yeah,
Yeah, thank you,
you.
Tony.
Yeah, thank you.
And we talked to Tony on the 30th. We'll hear
Right.
more about the
Yeah.
Hubble and the James Webb Telescope and
Sure.
yeah, all of that, Tony. I'm fascinated by those. It's time to celebrate all the tools that we have, our own senses, the expansion of the senses from the microscopes to the telescopes, from the microcosm to the macrocosm. We go exploring. That's just what we do as a species, and it's fun. And we're here trying to move the dial through dialogue. Yeah. That's what we're trying to do. Have an open, not a gaping mind, but really to ask the questions and to seek answers from fellow travelers. So, no, not a deity, a fellow traveler.
Yeah.
And we're appreciative of all that you've done and accomplished in your life, all the connections that you have and all the instruments that help to bring answers to this. And what an exciting beat you have. The cosmos
deal.
is my beat. Yeah, that's what Avi said. The cosmos is my beat. I'm like, wow. And it's really there for all of us, I want to say, to celebrate the stars, to understand our place in the universe. And Tony, we appreciate how you have encouraged us to find celestial markers in our own backyard.
Yeah.
And on the solstice, you're invited. And Tony and Paul will make a little bit of a presentation,
Yeah.
as well as their own experiential session. So just
All
to
that said,
celebrate,
yeah.
celebrate looking up and looking around. Thank
So
you.
Ed,
You've been such a joy, Ed. Thank you.
when we
Well, thank you very much for having
when we
me.
titled today's discussion, astrobiology and consciousness, is like that's quite a spectrum of conversation, and you've done it. You filled in the gap.
I want to mention that, this idea that we're already out there in a universe that is a cosmic womb of creation. Even when we talk to people like Brian Weiss and Raymond Moody,
yeah.
looking at, well, what are you finding? That's another way to explore. They often talk about the idea that people experience being in other planets simultaneously, simultaneous lives. There's another aspect.
Sure.
So this idea is not so foreign as you mentioned, Ed, because we talk with it all.
Yeah.
Right? We're here to explore it all.
Again, thank
Make
you
no
so much
judgments.
for joining us and your
Yeah.
fun and exciting presentation.
And thank your mother who brought you out there to look at the stars
Yeah.
and get you acquainted with your life's work at such an early age. So thank
Hopefully-
you for all the work that you do.
Hopefully, it was a warm climate. Yeah.
Where did you grow up?
Tennessee and North Carolina.
Okay.
Ah, very good.
Yeah.
And we're happy to talk to any of your colleagues that you think would enjoy hanging out with us.
They don't mind being pushed over the envelope a little bit.
Yeah.
Just
And also thank you for making accessible the leading edge of science to all of us here.
Yeah.
We're all curious. We're all living on this planet, looking up and looking around. We love to explore. Thank you.
Thank you all. Happy holidays. And this is a great show. I'm glad to learn about it.